Ya, Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. Today we will discuss about electrical reliability, the reliability in especially at power plant, electrical power plant industry. Firstly, we will talk about what is reliability. Every equipment have a lifetime. Every designer or every customer want every equipment have a lifetime that as long as possible. For the reason is um, we we want have more achievement. We more have uh, constant production high as we want, and usually we want not an equipment at our manufacturer, especially in power plant, breakdown at any time. So, for example, we have a power plant, mini power plant, for example, diesel engine power plant, or mini generator at our home. When we need electrical for our home or our industry, we want this engine is can energize on produce electricity for our industry when we need it. If we our if our industry run 24 hours or 7 days in a week, we want this engine for running every day without a failure or derating product. So electrical can sustain every time, every second we want, and our home can get electric power from this engine every time we need. So, but if this engine running every day, every time, on a year, and then second year and third year, absolutely this engine is made by our by human. But this engine will be fail or will be a problem someday. This problem maybe come from dirt, come from oil moisture, come from oil uh, contaminant from material that impact in internal engine because there is a mechanical equipment that rotating and touch each other. So when we don't want engine failure at time that we want it, we want not to have to become it. So we have to check every day, every time this engine to make sure that engine is didn't failure every time we need. So we can see the graphic at this presentation. For example, we have a new engine at the time zero, at the lifetime at zero. The condition is 100%. And then orbit. This is the initial start of our engine. Uh, At this condition, maybe engine does not didn't need does not need maintenance. That engine will can produce electricity 100% because they are a new engine. So, example, we have a new car or bicycle, motorcycle. The engine will perform very perfectly at this time. But in the partial time, maybe at the 1 year or sometime X hours, the engine maybe will be degradation. For example, we can see that time will be rise than before. For example, usually the engine operate at 40 degrees Celsius, then he rise to 50 Celsius or like this. So we can see that indication. So we will maintenance early, maybe change the oil and uh, some part at the internal engine. So the engine will be perform rise again and become 100% again. So if we does not any maintenance, we maybe the engine will be rise temperature and then engine will be breakdown at shorter time. And we absolutely we don't need we want it happen in our engine. We want it happen at our engine. So uh, if we doing maintenance, the predictive maintenance, we can see at the condition at our engine, maybe using temperature. We can see the oil condition. We can check the physics oil. We can see the parameter at the engine, everything for voltage, for frequency, for current, for power we send to the load. We can analyze that engine is help or there is something problem or there is a degradation. And already this engine sometimes because time due to time for some years we cannot afford maintenance that can be 100% again because a major part may be already degradation, insulation degradation, or mechanical part material maybe become fatigue because they touch each other for several years and then they already have a degradation. So at this point, we can uh, we can choose between we remove it or we use we can analyze using the cost. Maybe we can repair or we replace new one or we do do not do anything. We can analyze at this point. If we want our facility or our industry is still productive, they change the engine using a new one. If it can be can a profit, maybe better we replace the with a new one. Maybe for engine with a critical purpose that absolutely we don't want the engine become failure and become a big disaster in our industry. Maybe it's very important to replace the engine. Yes, we can already we can analyze for cost or uh, benefit and reliability analysis. Analysis. We can use at the some state of the lifetime of our equipment using the maintenance. Okay, and then some equipment will be aging and then breakdown and equipment breakdown broken. So we want to discuss about reliability versus aging. That one an indicator is very related. So aging is uh, same as reliability. There is a similarity. Reliability is defined as the probability that an item will perform a required function without failure under stated conditions for a specified period of time. So there is a point for reliability. There is a probability perform a required function without failure and under state condition for specified period of time. There is four part of the definition of reliability. Once probability, for example, is a timing chain might have a reliability goal of 0.9995. This would mean that at least 99.95% are functioning at the end of the state time. And then this is probability. Maybe it can be happen as the calculation 99.95%. It will happen, or maybe not. This is probability. And then required function. This should be defined for every part. Subassembly and product, the statement of the required function should explicitly set or imply a failure definition. For example, a pump's required function might be moving at least 20 gallons per minute. The implied failure definition would be moving fewer than 20 gallons per minute. Required function V1 is at least 20 gallons per minute. When the engine is moving fewer than 20 gallons per minute, this is not required function is rejected from this condition. And then the stated condition. This is environmental. This include environmental condition maintenance condition, usage condition, storage and moving condition, and possibly other. Usage condition, this is maybe reliability become lower because the environment is very high temperature, or less maintenance, or the usage condition is there is proper condition usage, or maybe storage and moving condition that possibly either does not perform at state condition for the equipment. And then the fourth the fourth component of the reliability is specified period of time. For example, a pump may be designed to function for 10,000 hours. Sometimes it's more appropriate to use some other measure of stress than time. Yes, hour is the simplest for analysis lifetime of our equipment. Maybe the second parameter to analyze the lifetime is maybe kilometer, or power plant electricity is megawatt hours, MWH, MWH. For example, the pump might be designed for function for 10,000 hours. Sometimes it's more appropriate to use some other measure of stress than time. Material reliability might be stated in the terms of mile, and that of a laundry appliance is in terms of cycles. Okay, and then the reliability, once again, reliability is defined as the probability that an item will perform a required function without failure under state condition for a specified period of time. And then aging is very related with reliability. The reliability related with the aging, already the other relation of reliability is safety and quality. When the equipment running with reliability condition, already it have a safe condition. For example, we have a car with the health condition and reliability 100%. It is the 100% concern that this car is safe for we operated. Also, the quality product of the component we use will be the output of the engine will be high quality. Okay, the source of the content is taken from the Certified Reliability Engineer Handbook at the edition. And then what is reliability tools that can measure or analyze to perform how to maximize reliability? One of the most common engineer use is FMEA. What is FMEA? Is failure mode effect analysis. FMEA is an engineering technique used to drive product and process reliability improvement. It is a structured analysis of a system or subsystem to identify potential failures, the, the cause of these failures, and the effect these failures will have on the operation of the product or process. So FMEI is to analyze the reliability of process or improve reliability. When conducting a FMEA study, failure modes should be investigated for possible safety risks. And once a reliable product is designed, quality engineering techniques are used to make sure that the product process produces the product. Okay, for example, FMEA is performed at the very early process. So the reliability engineering will be do FMEA at preliminary at the earliest condition can be do. For example, when the designer uh, design a house or engine, we will analyze what happened in the future of our design. For example, about how we, architect design a building, we can analyze how to maintenance the roof, how the wall, how the electricity, maybe electric, there is a problem, how we can do maintenance or replace a problem, and other example. So we can predict the early when this design is developed. When we can find problem at the design, we can improve it before we do or make a prototype, or before we build this design. So we can prevent the disadvantage of the loss of cost because the failure design at the early time. This is, for example, the FMAs will be due at the earliest time we can. At the design, we will do FMEA. We will do FMEA, and at the test, we will FMEA again. After, and then at production under operation, and after the end of lifetime, we do FMEA, because for the end of time, maybe we can make a better design at the next time for the better product. So this is by using FMEA every step of the every step of the product of the lifetime. Every time we can use FMEA tools for achieve highest reliability. So what is FMEA? How we can analyze or we can technically simple to do FMEA. Okay, and at the next time we will discuss about more deepest about FMEA. And now we will end for a break. Thank you very much, everyone. We will discuss about FMEA deepest, and then we can use some example and about aging and other at the next time. Thank you. Goodbye.